Hello, everyone. Thank you for joining us for our October Career Cafe on careers in construction and energy. October is Careers in Construction Month, for those of you who didn't know, and energy is our new trending career area, as that was just added as our 17th career cluster for Virginia. So we're very excited to have Andrew Krupacs from CMTA Incorporated and Adam Sledd from Dominion Energy Innovation Center as our guest speakers for today. I'm gonna go ahead and give it over to Mr. Andrew Krupacs so he can get us started with today's presentation. Thank you.
Give me one sec here. All right, good afternoon, everyone. My name is Andrew Krupacs, and I'm an electrical engineer. I went to school at VCU, and I absolutely loved my time there as a student. And I'm actually still regularly involved there with the engineering school and the current students. I graduated back in 2015, and I specialize into building engineering design directly out of school. I absolutely love the work I get to do, and I'm hoping that you all will leave this presentation with a little more insight of job opportunities surrounding this field of work. I actually grew up in Northern Virginia, moved here for school in 2009, and have been here since. I absolutely love it here in Richmond. Now, the time allotted today is limited, so I'm going to do my best to give you all a quick overview of what goes into creating a building and the jobs associated with that entire process. One thing that is very nice about the lines of work associated with this field is that there are job opportunities almost anywhere you go in the world, because there are buildings almost anywhere you go, literally. There are many engineering careers that lock you down, on the contrary, to a specific location, such as if you want to design cars, you're going to be stuck in Detroit. But this field literally lets you go anywhere. There's plenty of work here just in Richmond alone. So again, I'm here to talk to you all specifically about careers involved with the designing and constructing of buildings. There's a lot of information, and I'll do my best to give you all a brief overview with an overall concentration towards energy conservation and high performance building design. So essentially, high performance buildings are just buildings that are designed and constructed to use less energy than your average building. This is the future of building design, and I'm excited to share some details with you on it. So for all intents and purposes today, I want you all to think of designing and constructing as the two main careers and sides of building design that go into creating any building. So designing involves thoughtfully designing a building and creating instructions on how to build it. And constructing takes the drawings from the designers and physically creates that building. So just as an example, over here on the top right, I have an example drawing that is made from someone from the design team. This is specifically a power plan showing where outlets are and how to power HVAC equipment. And then over here on the bottom right, I have an example of a physical building that the construction team physically built in real life from those drawings. So now, generally, the design team includes architects, interior designers, and various engineers. I didn't list all the engineers that go into designing a building, but I went ahead and put the main ones that are involved with energy design on that side. So each one of these design disciplines plays a very vital part in creating high performance buildings. I went ahead and wrote a brief description of these roles on the slide so that you all can read along. Architecture is the design of overall layout of buildings. Interior designers design the interior environment of the buildings. And as far as engineering goes, electrical engineers design the electrical systems, mechanical engineers design the HVAC systems, and the plumbing engineers design plumbing and piping systems throughout. And again, these are all very important in making the building very energy efficient. Now, on the construction side, the constructing careers, they're going to be made contractors with very different specialties. Like how I said, there were like electrical engineers who design electrical systems. There's going to be electrical contractors who install those systems as well. Same for mechanical and plumbing. And then you also have general contractors who are going to build anything from the walls, floors, ceilings, roofs, everything else you could think of kind of in between that. Now, this is a lot of words here, so I'm just going to go quickly here. For education requirements for the design team, the architect's going to be about 4 to 7 years of school. Interior designer is going to be about 4 to 7 years of school. and an engineer is going to be right about 4, maybe 5 years of school, depending on where you go. So after education, all these designers who are making the drawings go on to further licensing in their field. And eventually when they're licensed, they get something called a professional seal, which is here on the right. The seal is what we put on our drawings, and it allows these professionals to legally design buildings. And before then, you have to learn under somebody. It's very similar to how contractors are going to do it as well. So general contractors, for instance, are going, any form of contractors are going to learn under people in the field to get that experience. So general contracting, you don't necessarily need a degree, but I'm sure, as April and Shannon will warn you guys here, that an education really goes a long way. I don't say that lightly. If you want to end up being like a foreman on the job or someone higher up on the contracting ladder, a lot of those younger people end up getting degrees and go into this field, and it really sets them ahead. There's a lot more than goes into just learning on the job. There's a lot of skills that go into just a lot of different skills you can pick up from a higher education or even just like an associate's program. Now, electrical contracting is going to be one of the most stringent ones. It's also one of the, when I say riskier, I don't want to say dangerous. It's just one of the ones that is possibly more dangerous job. You can work on somewhere from 4 to 6 years of training, and you become very specialized into it. I don't know how to describe that. You can work for utility companies working on really high powered lines. You can work on lines in a house, in a commercial building. But again, mechanical and plumbing is going to be similar, but it's roughly 1 to 2 years of training. And both the electrical, mechanical, and plumbing contractor, I just want to think of it like this. You can go to some programs for it. You can learn from actual employers. They'll pay for you to do it. You can go to trade unions. There's a lot of really unique routes into getting in this work. And I was going to say that if any of these things interest you, especially like working with hands, you should really seek out different opportunities, because there's a whole slew of ways to get into this field. So now that I gave you kind of the basic outline of who's involved with the building design, I just want to show you all an example of a project that my engineering firm worked on, and it's one of our highest performing buildings we've designed yet. So compared to other similar schools which were built around the same time that this one was built, this school building uses a little more than half the building in comparison to these similar school buildings, which is pretty incredible. We got the usage really down low. The level of performance of this building would not be possible without everyone from the design and construction team coming together to make this happen. Now here's where it gets even cooler. So this building, actually I'll go back here. The power cost for this building is roughly $60,000 a year in power. But this building generates more power via solar panels in a 12-month period than it consumes for the power company. So in turn, this school building ends up having $0 in energy bills for the year. The electrical engineering team calculated how much power the building would need in a 12-month period, and they did this with working with the mechanical and plumbing engineering teams as well. Now keep in mind that like HVAC systems and water heating account for the majority of electricity used in a building. And it's also neat because it's only in recent years with the solar technologies that have improved to such an extent to make design like this possible. So this is specifically something we call net zero energy design. And it's something really cool that we're getting more and more involved with. So to have enough area on the rooftop for all the solar panels, we had to talk to the architect and interior designers a lot, and they had to add additional spaces with overhangs to accommodate additional area required to fit all the solar panels on the building. If you see here on the right, that red box, I boxed an example of an additional overhang that was partially added for this specific purpose. So again, to make this building energy efficient, it takes everybody working together to make it happen. Now, the electrical contractor really drove this one home. They had the experience and know-how on how to install the entire operating solar PV system, and they did a fantastic job in doing so. We had next to no problems with it. Again, the contractors have this experience from learning from older people who are already in their field, and it's very important for us because we have to rely on them to do their part of the job correct too. Now, this is a photo of the cafeteria of this school. This space primarily is illuminated from natural lighting coming in from the sun. And it's neat. It has light sensors throughout that dim or even turn off indoor lighting when there's enough illumination from the sun. So you can just get natural lighting in the space. So this feature of the lights naturally dimming and saving energy costs occurs regularly throughout other areas in the building too, not just the cafeteria. So on the bottom right, you should remember this snippet on the slide where I was showing the additional solar panel that was needed in the rooftop box in the red. This overhang is above and on top of the same cafeteria, and we position this overhang in just such a way that the sun glare is reduced when the sun hits the hardest in the side of the building. So the picture on the top right is just another angle of the cafeteria that you see there. It's very cool because when you have a lot of sun glare, it brings in a lot of heat in the building, and people usually lower their blinds and never pull them up. So it was very cool to implement that. Now, the last thing I really want to touch on, that I mentioned HVAC and plumbing systems earlier that are the largest electrical load and use the most power. For this building to have generated more power than it uses, we had to make sure the building used the absolute lowest amount of power it could. We installed incredibly efficient systems that have a higher price tag up front, but some of this system will have a lifespan almost 50 years. And mechanical plumbing engineers and mechanical plumbing contractors played a critical role in making this whole net zero energy concept possible. So I just want to drive home, whether you're designing or whether you're actually building it in the field, plays a huge part in the final design of it, final outcome of a building. It's a very cool thing to be a part of. This is one of the few lines of work where you get to draw something and then see it done. And this is just a few things I want to say. Here's a chart showing meter data for the building regarding how much energy is used and produced. And the orange line is how much the building needs. The blue line, the blue line there is what the solar panels are actually generating. And this is just a screenshot of the school's website. Ironically, it's broken right now, but it would usually show live metering data to show how much solar is being generated, and then how much the building's used. And usually during the day, when that sun's out, it's creating far more power via solar than it's actually using. And one last thing is my background is engineering, so it's easy for me to talk about the engineering features and like electrical features of this building. Like engineering wise, this building won numerous design awards nationally, but architecture and interior wise, numerous awards were also won. And I think it's something that I just want to mention here while we're here, even though we're concentrating on energy. The architects and interior designers did a fantastic job of making these spaces incredibly welcoming and useful. Like right here on the bottom left is just a corridor coming through the space, very unique ceiling, very open, different levels. And then on sorry, I looked at the wrong side. Then on the top right there is actually part of, it's like a nook in the library that's used for different space in there. This here, the top left is a picture of the gymnasium. And then the building on the bottom right is going to be an outdoor play area. Again, my last thing, I just want to reiterate how much coordination goes between designing and construction teams to make this building happen so flawlessly and really efficient on power. So I guess no one else is here. I was going to say, are there any questions? What do you think, Shannon?
I think that what we are actually going to do is we are going to share out this video today that you are doing with all of our teachers and classes. And I did want to ask if they have questions beyond today, would you suggest they reach out to us to reach out to you directly, or what would you prefer?
Either one is fine with me, Shannon. You just let me know how you want to do it.
Okay, we appreciate that. No, thank you very much for sharing that information. And definitely the visuals are very helpful for us and for our students, so appreciate that, Andrew.
I hope they did. I tried my hardest there. And if any one of your students is interested in pay or training, I'd really encourage them to look up online. I think one thing, when you say like 4 to 7 years of experience plus numerous testing to become an architect, or 5 years for engineering, it sounds intimidating until you get in the real world, and every career has those kind of requirements either way. So I think the idea is like to get started, if you have any kind of passion or interest, you should really go online and kind of see what kind of pay opportunities there are in your area and training, because it is going to vary like area to area, state to state.
That's really good advice. Thank you.
Yeah, I figured the students would want to know something about that. So.
Yes, definitely one of the biggest questions we get is on the schooling piece, so thank you.
Yeah, of course.
Okay, so we're going to pass it over to Mr. Adam Sled, and so he's going to be sharing some information with us today.
Yeah, very cool. Thank you for having me.
Thank you for joining us.
Let's see. All right, I have got all of 3 slides here, and then I'll see if we can do. I'll show some websites of some of our startups. So real quick, hi, my name's Adam. I run the Dominion Energy Innovation Center here in Ashland. We're a nonprofit. We're a clean tech incubator and a small business resource center sponsored by Dominion Energy. So while we are not technically part of the utility, we work very closely with the utility and the county and the town of Ashland to help out entrepreneurs. So our focus is helping entrepreneurs build and grow their businesses, especially entrepreneurs in Hanover who do any type of business. But what we really love is working on clean technology like renewable energy and energy related startups. So if you don't know what a startup is, pretty much every business you can think of was a startup at one point, right? It was an idea. A guy, somebody like Andrew does their job for 10 years and then they have an idea for how they could do some part of it a lot better than everybody else is doing it. And so they decide to go off and start their own thing and build that idea into a piece of technology and then build a company around it. And so my role at the Dominion Energy Innovation Center is to help those people who are trying to build those ideas into companies. And what we really like doing is seeing people with new ideas, new technologies, and work with them to build that into sort of a full-fledged company. Because what you have to do, the difference between having an idea and having a company is, you have to understand the financial and accounting impacts of what you want to do. You have to build a business model. You have to think about who you want to hire and how you want to hire them. You have to think about how you're going to market your product, how you're going to sell your product, who you need to sell your product to. So it's a whole, building a business from the ground up requires a whole lot of different skills. My background is, let's see, I have a media studies degree in undergrad because I like storytelling and I like being interested in lots of different things. So I wound up in something where I get to touch on a whole bunch of different pieces of business every single day without ever having to focus on one thing for a really, really long time. It's like the opposite of probably what Andrew does. So I've been involved in 4 different startups, different things ranging from a magazine to green building. I have a media degree. I worked in film for a while. I worked in commercial real estate for a really long time, like 12 years. I did nonprofit management before I did this, and I worked in nonprofit on energy efficiency. So kind of like what Andrew was talking about, how we helped companies think about and how to build more efficient buildings. So that's all the different stuff I did before I wound up here, which I guess makes me qualified to do this because I know a little bit about a lot of different things. So, so what we do in our center on a daily business is just work with different entrepreneurs who have different products and technologies and companies and help them think through things like, how are you going to find your customers? How are you going to sell to those customers? How are you going to build out your website? How are you going to build the next prototype of your technology? So this is kind of what we do. Sometimes we do things like hold pitch competitions where we bring in a bunch of different entrepreneurs to Randolph-Macon, and we have judges and we let them pitch their ideas, and then the judges pick the ideas that they like the most, and we write really big checks, and that's a lot of fun when we get to do that. Most days, this is our space. So most days when there wasn't COVID, we would have a bunch of different business owners come in and hang out and get to know each other. We would do networking opportunities to come meet with like the town economic development team and learn about what they're thinking. So really just ways that we try and bring people together to kind of create networks, get new ideas happening, make connections between different types of businesses. So, you know, if you're an insurance broker and you have questions about hiring practices, like you want to meet an HR consultant, or you want to build a new website, so you need to meet a digital marketing team. So one of the things that we try to do with our space is sort of create these collisions of bringing different types of small businesses together and then let them meet each other and kind of have their conversations. And that helps spark sort of new ideas and new services. So if you bring 16 different types of service providers together, they should come up with all kinds of new connections that can create new ideas and increase revenue for their business. So that's one of the things we like to do a lot of. On the energy side, so specifically what we're doing around the energy side is we created something called DeicAccelerate, which is a program where we work with really young energy focused startup companies. And we're connecting them with Dominion Energy employees and sort of helping them find their way into the right part of Dominion. So MOVA Technologies is like the map view of our current group. MOVA Technologies down near Blacksburg, those guys are working on a technology where they would take basically sorbents, so it's like a sand type of material, and they would put it near like a natural gas power plant, and it would capture the pollutants coming out of the flue as the gas is burned to create energy. So like if their technology works, it would basically pull all the pollutants coming off of natural gas power plants, right? Which would save those from going out into the air and being a pollution problem. But for them, what they need to do is they need to create a prototype. They need to test that prototype. They need to figure out what works and what doesn't work about it. Then they need to go back and create prototype number 2. And then they've got to keep working to make those prototypes better and better. And while they do that, they need to be working with Dominion Energy to identify like, how much does this thing need to cost for you to be able to buy it? How big does it have to be? How quickly do we need to deploy it? So they have to answer all these questions while they build this product in order to make sure that they're building it with their end user in mind. So what we do is we make that connection, right? We get the people from Dominion, we get the guys out in Blacksburg, we put them in the same room, and we say, all right, guys in Blacksburg, ask Dominion a bunch of questions. And they're going to give you a bunch of answers. And then we're going to send you away to go make the next prototype of your product. And you'll come back when you're ready to ask a bunch more questions. So right now we have 7 different teams from around Virginia doing that. And each of them does a different really cool thing. So I was going to pull up one of them. There we go. So this one is Lumen. Be really quick. What Lumen does is actually sort of in the realm of what Andrew works on. But it allows you, it's a little box that attaches to the circuit breaker in your house. And then you have an app. And what the app allows you to do is it allows you to control each individual circuit on your house remotely from your phone. So say if you're one of those people who put solar on your rooftop at home and you have like a battery system in your garage to manage it, in the event that you are using that battery for your power at home, or like the power goes out and you're just running your house off the battery, you can pull up your phone and you can say, all right, I want to turn off power to my kitchen and turn on power to my bathroom and my bedroom. And then I'm going to turn off power to my living room and turn on power to the garage, which is sort of a brand new idea technology wise. And these guys came out of UVA and they're distributing their product all over the country already. And we're helping them sort of think about what the next generation version of that looks like. The other one I want to show you, which hopefully the video piece of their website's working, is Linebird. Linebird is really, really cool. These guys are from Richmond. And There's 3 guys. 2 of them are drone pilots, and one of them is a product engineer who figured out that you know, big power lines that you see like on this video that are like 30 feet tall, you know, out in the woods somewhere. The way that the utility checks to make sure that those power lines are functioning is they put a guy in a cage and attach the cage to a helicopter and fly the helicopter along the electric lines. And the guy hangs from the cage with a big stick and touches the stick to the power lines and hopes that it doesn't shock him and kill him. And that's how and the stick, you know, tests to make sure that the power line is working correctly. Well, that is an insane way to do something. And it's very costly and people die. So Linebird, these guys came up with a way to do the exact same thing, but use a drone instead. So there's no person touching a stick to a power line. So we're working with them, and they're currently testing with Dominion how effective it is to use a drone with the same stick attached to it. But if they're successful, this will be the way power lines are tested, you know, 10 years from now, all over the world. So they're really fun to work with because this is a great example of the way things are done currently doesn't make sense. They're done the way that they are because it was the only way we could think of to get it done. It's expensive and it's dangerous. And so we can use new technologies to do things in a much better, more effective way, but you have to like build a whole business around that idea. So that's what the Linebird guys are doing. So they're just another example of who we're kind of trying to help. So yeah, we're right down in downtown Ashland, and some of the companies that we work with are here in our space on a regular basis, and some of the companies we work with are like out in Blacksburg or up in Nova, and we work with them virtually over Zoom. So I spend a lot of my time in Zoom meetings, and that's, you know, that's probably good for now.
Thank you, Adam. We really appreciate that information. That's so interesting. I never knew how people tested power lines before, so I'm sure our students didn't either. And this has all been really great for our students that are really thinking about different job areas they want to explore further, want to find out more information about. So we really appreciate both of your time today. This has been really informative. We really appreciate it.
Absolutely. Happy to help.
Thank you.
Everyone can feel free to reach out. I mean, one of the things we're starting to do a lot more of, mostly for college students, but we're providing our companies that we work with in our space or other places in Virginia with interns. So we're trying to get more, at least college students involved with these startup companies as they go.
That's wonderful. That's a great opportunity for them. Love that. Well, thank you guys so much. And yes, students, if you have any questions, feel free to reach out to me, Mrs. Corbin, or Mrs. Edwards, and we can get you into contact with these wonderful gentlemen here today. And thank you, everybody. Have a great day.
You as well. Thank you, April.
Take care.
Thank you.